Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we are dealing with indices with algebraic expressions. Now, before we get going, something really important. We have learned indices to do with numbers already. If you look in the number strand and if you work through that, you should know all your 9 rules of indices in regards to numbers. Here they are. These are the things you should be able to either evaluate or say what they mean for any particular number A. So I'm using algebra here to generalize. I want you to pause the video and for each rule either say what this means or work out the answer, or show me that you know what it means. Right, I'm going to do that for you now, and hopefully you can have a look through here. A to the power of n meant a multiplied by itself n times. So for example, 3 squared means 3 times 3. 3 multiplied by itself twice. Anything to the 0 is 1. 3 to the 0, for example, is 1. Anything to the power of 1 just gives you the number itself. 3 to the 1 is 3. A to the power of negative n. That means 1 over a to the positive n. So 3 to the negative 2 means 1 over 3 squared. 3 squared is 9, so that's 1 over 9. A to the 1 over n means the nth root of a. So for example, 27 to the 1/3 means the cube root of 27, which is 3. A to the power of m over n means the nth root of a like above, but then raised to the power of m. So 27 to the 2/3 means the cube root of 27. Work that out first and square it, and you'd get 9. And the multiplication rule, if the base number is the same, you can add the powers. So 3 squared times 3 to the 5 is 3 to the 7. If the base number is the same, you can subtract the powers. 3 squared divided by 3 to the power of 5 when you're dividing is 3 to the 2 take away 5, or negative 3. And the power of the power rule, a number to a power, all of that raised to a power, you can multiply the indices. So 3 squared all to the power of 5 would be 3 to the power of 10. Now that is an absolutely quick stop through indices. If you don't know these and know these basically like you know your own reflection, you're going to struggle in this video. So go back to number and learn these and work through all the videos for indices there before you start this video. If this is all familiar to you, then we're ready to go. On the assumption you know those rules, let's get on and use all of these rules with algebra. Let's start straight with examples. We're asked to write the following in index form. 2 times 2 times 2 times 2 times 2. Well, we know that stuff. That's just the same as 2 to the power of 5. Now, this is where we're using algebra at last. Not numbers anymore, but x times x times x times x times x. Well, we would just write this in index form as x to the power of 5. The base here is x. The exponent, or the power, is 5. It's just like above, but x is in place of the 2. What about the next one? Well, can you see this here is the same as this? And we know that's x to the power of 5. But you've just got a 2 in front of it. So you've got 2 multiplied by x to the power of 5. How does a mathematician write that? They write that as 2. They don't write the times sign x to the power of 5. Just like that. But something very different below, and I hope you can spot this. This is 2x multiplied by 2x multiplied by 2x multiplied by 2x multiplied by 2x. What does that mean? Well, it's 2x is your base there, not x. 2x is the thing you're multiplying by itself raised to the power of 5. So you must put a bracket to show that it's the 2x that you're raising to the power of 5, not just the x. And this is a common mistake. Students mix these up all the time. 2x to the power of 5 means something very, very different from 2x all to the power of 5. If you look at it here, you've got 2 multiplied by itself 5 times here, which will actually give you, if we were working out, 32x to the power of 5. And that's so different than 2x to the power of 5. So this means x to the power of 5 multiplied by 2. This means 2x multiplied by itself 5 times. And the two are really different. Although they look similar, the bracket tells you that they are very different. So make sure you look out for that and you understand the difference here. Right, next example. Write the following in index form. Pause the video, have a go yourself. Well, x multiplied by x multiplied by x is going to equal x cubed, and y multiplied by y multiplied by y multiplied by another y is going to be y to the power of 4. And we don't write a times sign, and we're done. What about the next one? Well, because multiplication is associative and commutative, we can multiply in any order. I'm going to take the x, multiplied by that x, multiplied by that x, and I'm going to write them in alphabetical order and say that's x cubed. Then I'm going to look for the next in the alphabet, which is y. So y multiplied by y multiplied by y, I'm going to write as y cubed. And lastly, we've got a z there. Don't forget we've got this z on its own, and we're just going to write that as z here. Because we're asked to write in index form, we should write z to the power of 1 like that. And we're done. So what about the last one? Well, we've got a's, b's, c's, and a number. We generally always write the number first. So there's only one number there. Let's write that first, that 5. Now let's go in alphabetical order. We'll go for a's. We've got 1a multiplied by another, which is a squared, multiplied by another, which is a cubed. Done with a's, good. Now let's go for b's. We've got 1b multiplied by another b, which is b squared. So write that in next. What have we got lastly? Well, we've got a c multiplied by another c, which is c squared, which we'll write at the end. And we're done. And the last thing I want us to do is just think about powers of 1 and 0 with algebra. Okay? So I'd like you to either simplify the following or work them out, evaluate them if you can. Well, x to the power of 1, anything to the power of 1 just gives you the number back. In this case, x to the power of 1 just gives you x back. Anything to the power of 0 just gives you the answer 1, that's right, even y. 2 to the power of 0, 3 to the power of 0, bob to the power of 0, y to the power of 0, always 1. Now, this is really, really important here. Before I tell you, can you think how 2 y to the power of 0 is different from brackets 2y, close brackets, to the power of 0? Well, it's to do with BIDMAS. Let's think back to BIDMAS. Do you remember? BIDMAS said brackets first, then indices, before division and multiplication. So, looking at this here, this means, remember, 2 multiplied by y to the 0, doesn't it? That's what that means. And we should do the indices first. Y to the 0 is 1. And 2 multiplied by 1 is simply 2. So the answer to this one is 2. But what about this one? Well, using BIDMAS or order of operations, we're supposed to do the thing in the bracket first. So imagine you could multiply 2 and y and get an answer. Then whatever that is, you raise it to the power of 0. Anything to the 0 is 1. So this one actually gives the answer 2, and this one actually gives the answer 1. So 2y to the power of 0 is extremely, extremely different, and we need to know that, to 2y with brackets around it to the power of 0. And I've mentioned that earlier on in the video. It's something you've got to be careful of. When you see brackets, everything is raised to the power of 0. When you don't see brackets, only this thing here is raised to the power of 0, or whatever power it indeed is. And the 2 is simply multiply, whereas in this case 2 is part of the base number, which is 2y. And that's it for this video. Everything you need on an introduction to indices with algebraic expression. Thanks for watching.